Hey everyone, welcome back to another Autodesk Fusion tutorial. If you saw the thumbnail of this video, you kind of know what we're making. We're going to make a very simple jar, but it's going to be a parametric model. So we are going to be able to change the height, the diameter, and the wall thickness just on the fly using parameters. So I thought about making the threaded portion of the lid also parametric, but that gets a little complicated, and we're gonna maybe save that for another video. So, okay, let's get started. So let's add in a few parameters that we know we need for this model. So you can either click this button right here, or you can click on Modify and go all the way down to Change Parameters. And by the way, if you do not see this button up here and you want it there, when you come down to change parameters, you see these little three dots come up. You can click on those three dots and make sure pin to toolbar is checked. So let's get back into parameters. When you're in parameters, what you're going to do is hit this plus symbol, and we are going to name the three parameters we're going to use. So we're going to do diameter, and you have to put in a value. So, and the units are millimeters. So we'll do 50, and then we're going to do height, and we'll just keep this at 50 as well. And then we will do wall thickness. Now you can see that I'm not adding spaces. I usually would capitalize this. You cannot put a space in your parameter name. You see how that turns red? So I either, if it's not a very complicated model, I usually just type it all out with no spaces, or you can add like an underscore or something like that. So wall thickness will do 2 millimeters and hit OK. And so those are the only three parameters we need for this model. So let's hit OK, and let's start creating our jar or our container. So let's go up to Create Cylinder, and we're going to choose this bottom plane here. And then we'll click on the origin, move our mouse out, and we'll just kind of make it real quick. I'm not going to hit enter to get out of this because I want to add our parameters. Now there's a few ways you can do it. The first time before I clicked, you could have typed it in for the diameter, and then now it's asking for the height, or you could just come over to this window here and do it here. So diameter, if you remember, we can just type in diameter because that's the parameter we put in. And you can see it adds a little FX here, right, for the parameter button. And for height, we'll just type in height. And now this should be 50 millimeters in height and 50 millimeters in diameter because of these two parameters. So we can hit OK. So now let's make the threaded portion of this. And before I do, I'm going to create a cylinder just so I can kind of explain it first. So let's create a cylinder on top of this and hit enter. Okay, so basically how I make jars like this is I want this space right here. So from this line to this line, so from here to here, that distance needs to be the wall thickness of the jar plus 1 millimeter. So if we had a wall thickness of 2 millimeters, this would have to be 3 millimeters from here to here. So I'm going to go ahead and delete that cylinder I just made. So we can come down to the timeline here and just hit delete. Let's create the cylinder again. I just created that so I could explain it. So let's go to cylinder. And if you don't know, you don't have to choose one of these planes when you try to create these solid bodies. You can also pick surfaces. So I'm going to choose this surface. I'll click on the origin and drag out. And like last time, I will just do everything from right here. I like doing this because I can actually make this longer, especially when I want to type out a formula. So the height, we'll just keep at 10 millimeters. So for this jar, the height of these threads will always be 10 millimeters. You can make this height whatever you want. So for diameter, we're going to have to do some math here. So we're going to do the diameter, which we have set at 50 millimeters. And you can see that it automatically takes that out to 50 millimeters. And we're going to subtract the wall thickness plus 1 millimeter. and we have to multiply this by 2. And we multiply it by 2 because we're dealing with a circle here. So, we want the wall thickness plus 1 millimeter on this side and the wall thickness plus 1 millimeter on this side. So it's doubled, if that makes sense. And we want to make sure this is set to join. That way this new cylinder joins with this bottom cylinder. So let's hit OK. So now if we did this right, if you remember with the parameters here, our wall thickness is 2. Oops, I can't click on these edges while I'm in here. So if I click on this and then hold shift and click on this, this should be 3 millimeters, which is the wall thickness plus 1 millimeter. And so if we change this to, let's say, 1 millimeter, this should change to 2 millimeters. So let's click this line, hold shift, click this line, and now we're at 2 millimeters because it's always going to be the wall thickness plus 1 millimeter of space. So let's just bring this back to 2. Okay, so let's set up an analysis before we continue. And so basically we're going to do a section analysis just so we can see what the inside of this jar looks like. So let's go up to inspect. We're going to go down to section analysis. And again, you can choose a surface, but I want to cut this model in half. And since we started from the origin, we're going to cut it in half from this plane, this front plane. And you can see it's backwards. I'm in the front view right here. So all you have to do is hit this little flip button and it flips it around and you can hit OK. Now this is not actually cutting the model in half. It's just giving you a visualization. So basically cutting the model in half so you can see what's on the inside. And you can toggle that on and off with this little eye right here. So let's hollow this out, or shell it out, you would say, in Fusion. So there's a tool right here called the shell tool. And again, if you don't see these tools, so you see this vertical line here and this vertical line here, all the tools in here are under modify. So you can always find them in here. So shell is right here. So we'll select this top surface, which will be the open surface of the shell, and we're going to just type in wall thickness and hit OK. And so let's turn that analysis back on, and now you can see it gave us our 2 millimeter wall thickness throughout this whole solid body that we created. Okay. Since most of my stuff in Fusion has to do with 3D printing, we're going to take a step here to correct this overhang. If you were not 3D printing this and for whatever reason you just wanted a 3D model of a jar, you would not have to do this right now. So basically what we want to do is chamfer this. However, we don't want to chamfer. Let's see if I can actually find. So that's 3 millimeters. Yeah, we don't want to chamfer like this. So I'm just going to hit 3 millimeters and hit OK, because now watch what happens. If I do a wall thickness of, let's say, 5, now look, that chamfer messes up and we have an overhang again. Maybe there's a mathematical formula here. I wonder if it's the same. I wonder if this line, let me hit OK here. No, 6.7. So let's undo this. So let's just pick this back to 2. I'm just going to delete that chamfer. So I'm going to go down to my timeline here, right click and hit delete. And I'm going to show you a better way. So this chamfer is always correct. So let's start a new sketch right here. We're going to just draw it right on that front plane. And we're going to go up to create, project, include, and intersect. And basically what this is going to do, it's going to draw an outline of what that plane, what my sketch plane is intersecting. And you can either choose specific lines, so I can go through here and click on the surfaces and lines that I want, or I can just click on the whole body and select the body and then hit OK. So you can see there's my sketch. That plane we drew on goes right through the middle and it just sketched out that body. So if I hide this body, there's our sketch. And so what I want to do is just draw this chamfer in. So I'm going to hit L for line tool. I'll click on this line here. And you can see there's two options here, the length of the line and the angle of the line. So I'm going to hit tab, so I'm on the angle, and I'm going to type in 45. And now that angle is locked in at 45. It can only draw at a 45-degree angle. And I'm just going to move my mouse till it kind of snaps to this line and click. And then we will finish sketch. Now, one thing to note, which I guess I should go back and show you this. When I did a project include, let me just get back into this sketch. When I went to create and project include intersect, you have to make sure this projection link is on. And what that projection link means is that when you select this body and it draws this sketch, when projection link is checked, if this body changes, so will this sketch, right? So if we start doing our parametric, our changes, and we change the shape of this container, this will now update. This sketch will now update to fit the size of the jar, where if we were to leave this unchecked, this sketch would not change after we change the size of the jar. I hope that makes sense. That's really important. So let's get back out of here. Okay, so now what we want to do is sweep this chamfer around this jar. So I'm just going to turn on analysis again, which kind of cuts it in half. It gives me a better view of this sketch. I'm going to select the sketch profile, and we're going to go up to sweep. And we already have the profile selected, and now we need to select the path, which you could choose this one or this one, and make sure it's set to join and hit OK. And there, that chamfer goes all the way around now. So let's update this and see if it works. So let's do a wall thickness of, we'll go back to that 5, a wall thickness of 5. And look what happens. That chamfer updated with it. And we could go back down to, let's just go back down to 2. We could change the diameter of this to 34, and it updated. So it's exactly what we want. Change that back to 50. Okay, so now we have that working. So now let's start making the lid. So for the lid, we want the same thing. We want this lid to have the same wall thickness with a 1-inch gap here. The lid has to be tall enough to go past the 10 millimeters plus a little gap plus the wall thickness. Hope that makes sense. So let's create another cylinder. And this time we're going to draw it right on this plane. And then we will click on the origin again. And this time, instead of finalizing this, we'll just type it right here. So remember, this first one is the diameter. So we're just going to type in diameter, hit enter. And it's set to cut right now. And we want this to be a new body. Now the height, if you remember, the height of this thread is always going to be 10 millimeters. So we're going to do 10 millimeters plus wall thickness plus, you can pick now the gap you want. So let's just do maybe like a 0.5 millimeter gap and hit enter. And I'll show you what this gap is and hit OK. So now we have 2 bodies, and we can name this. So this can be jar. This can be lid. And let's turn our analysis back on. And so when we shell this out now, so let's click on, actually, let's just hide the jar so it doesn't get confusing. We'll hide the analysis. So here's the bottom of our lid. We're going to click here, go to shell, type in wall thickness, which is set at 2 millimeters right now, and hit OK. Turn our jar back on and our analysis, and there we go. So now this lid will always have the 2mm wall thickness on the top, 2mm wall thickness, or I shouldn't say will always have 2mm. It'll match the wall thickness of this jar with this 1mm gap here, and we did a 0.5mm gap for the lid. So let's go and change our parameters. Let's do like 1.8, which is kind of like a gridfinity thickness. Then you see how the lid updated. So if we did 4, there, that lid updated, and it keeps that 1mm gap. Okay, so from here, let's start working on the threads. And this is kind of my technique for threads that I've developed. They almost always work for me pretty much every time on the first try. Now, if you make this jar really, really big or really, really small, you might start running into problems, but any reasonable size jar and threads pretty much always works if you follow this method. So let's hide the lid and let's take the analysis, and we'll turn that off. And let's start creating some threads. So I'm going to go up to Create, Coil, and we're going to start, oops, let me backtrack here a little bit. I'm going to hit Escape. I want to create a construction plane, an offset plane. So we're going to click right here, and I'm going to click on the top surface of this threaded area. And it wants me to put in a height for this. And I'm going to do -2, just so we're not starting right at the top of this threaded portion, and hit OK. Now we're going to create those coils, or that coil on this plane. So I'm going to select this plane, and I'm going to click the origin again. And I basically want this right on the outer edge of this threaded area, minus 0.2 millimeters. And so let's just click, and that way we can bring this out so we can make our math equation again. So let's just clean this up a little bit so it's not so crazy. So let's just go to join. We're going to do the section size at 2 millimeters. The revolutions are is going to be 0.75. The height is going to be -6. And I think -6 is what I want. Yeah, and I'll explain that. Well, it's easy to explain, right? We came down 2 millimeters before the start, and now we're ending 2 millimeters, right? So 6 plus 2 millimeters plus 2 millimeters is 10, which is the height of this threaded area. But our diameter gets a little trickier, and I didn't practice this first, so I might have to figure this out as I go. So the diameter of those threads is going to be diameter, let's see, minus the wall thickness plus the 1 millimeter gap multiplied by 2. And again, that's kind of like we did for this space here. So that gets that thread, circular thread, right in the middle. Can I turn analysis on? But we want to inset it just a little bit more. So now we're going to subtract 0.2. Now you should pause this video and copy this. Just so we created the diameter, which would take us all the way out to this edge here. We're going to subtract basically this here, which is the wall thickness plus 1. But remember, we have to do it for both sides, so that's why the multiplied by 2. And then I also want this circle, the thread, to be inset by 0.2 millimeters more, which is why we subtracted another 0.2 millimeters. And this only works, so I guess a few other things you need to check is that you make sure this is on circle and you make sure this is on center. And then we can hit OK. So let's just take a look. Let's turn the analysis off, and this is kind of what it should look like. So you can see now we have a nice gap here, and if we circle around, we have that same gap on the bottom. So let's chamfer these edges. And since I've done this before, I already know the number to do here. So we're going to go up to chamfer. A lot of times I'll just use the move tool, and I will rotate this face to give it to kind of cut this in. But when you're doing a parametric model, you don't want to use the move tool if avoidable. So I'm going to click on this line, hold shift, and click on this line. And we're going to do two distances. Now this arrow right here going out is going to be 4. And if you hit tab to go to this arrow, it's going to be 0.89. And hit OK. And that just adds a nice transition there to that thread. Again, if you are not following my measurements for these threads exactly, those numbers will be a little different. Okay, so now we're going to actually pattern this so there's 2 threads, right? It's going to be a 2-start thread. So let's go to pattern. We're going to do circular pattern. And we're not going to pattern bodies, we're going to pattern features. And we're going to pattern the coil and the chamfer. So you'll see this selected down here in blue. Also up here, you'll see 2 selected. The axis, you can either choose the Z-axis here, or you can just choose the circle you want to pattern around. And now it's doing 3 of them. So we just want 2 and hit OK. And now we've got 2 threads. And what this means is when you put this cap on, it'll be able to start threading in 2 different spots. So it's way easier to put that lid on. And then also it only takes a 1/2 to 3/4 of a turn to thread it on. Okay, so now we're basically going to do the same thing to the lid, but I think the difference, and again, I'm not 100% sure about this, we'll find out here in a second. I think instead of subtracting this right here, we have to add it. So what I'm going to do is just select this, and can I copy? File. I don't know if I can copy this. Maybe on the keyboard, hit, what is it, Control C? We'll see if that works. And hit OK. Okay, let's do the same thing with the lid. So let's kind of rotate so we're upside down. Remember, we're going to do a offset plane right here. And this is not as critical actually, because really doesn't matter where the threads end here, but we'll just to keep it consistent, we'll do -2. So we're starting 2 millimeters down from the edge. We will do a coil on the plane we just drew. And now this time we need to come to the inside of this. So let's figure this out. Let's see if this worked. Control V. Hey, look at that. It did copy. So let's just get all of our stuff right. So the revolutions is going to be 0.75. The height, what do we do? 6. And the section size is going to be 2. And we're going to join this. So the only thing we have to do is the diameter here. And you can see it got it pretty close. I'm just going to do a bottom view here. So I think we have to change 2 things. I think we subtract, instead of a plus here, we do a minus. That's not quite right. I think actually we don't need this at all. And I think if we get rid of this, I think we do plus 0.2. Yeah, because without this 0.2, watch this move. Without this 0.2, it's directly on the center. These threads are right on the center, and we want it to move out by 0.2. So we're going to do plus 0.2. So this coil is just the diameter Oh, that makes sense because we're just doing the wall thickness of this lid. So when we do the diameter of this, we're doing the diameter, which is that 50, minus the wall thickness, which gets us right on the center. But then we're adding, oh, then we have to multiply by 2 because of both sides, and then plus 0.2. I hope that makes sense to you. I always have to think about it. Okay, but look at this. It's going in the wrong direction. So I think what we can do is add a negative sign. Did that work? Let's see here. Can't do negative diameter. Let's put all of these in parentheses. My brain's not braining right now. Oh, geez, I'm in totally the wrong spot. Okay, forget everything I just did there. Okay, this is what we want. That gets our diameter exactly how we want it. The reason it's going up is because the height needs to be -6. Sorry, I'm losing my mind here. There we go. Okay, so remember these settings right here and hit OK. So let's do the same thing to these edges here. So we're going to select that edge, rotate around, select that edge. We're going to hit the chamfer button. We want the 2 distances. So the arrow going out this way is going to be 4. And so we'll hit tab, and this will be 0.89. And hit OK. And like before, we will pattern this. So click on the pattern button, switch it to circular pattern. It's already on features, so we can select that coil and that chamfer. The axis will just be this ring, and we want to make sure we have a quantity of 2 and hit OK. So let's turn the jar back on, and then we'll do the analysis. And now this is what your thread should look like. You can see we've got a nice gap here and some clearance for the threads to work. And like I said, this works for me pretty much all the time. And now the only thing left to do is some cleanup. So we can select this edge and do a chamfer here, maybe like 0.5. Make sure you're not chamfering so much that it's biting into this thread. We can do a chamfer here, and we'll do maybe like a 1 millimeter chamfer. Hit OK. Oh, you know what? One thing we forgot. We should be chamfering this inside edge. So we can just click this, hit 3, maybe a 3 millimeter chamfer, whatever chamfer size you want there. And let's chamfer this lid. So we'll chamfer this at maybe 1 to match the bottom. We'll chamfer, oops, let's hit OK. We can chamfer this maybe at 1. Actually, let's just do 0.5. And we could chamfer the inside of this ring here to make it slide on better. We'll do 0.5. Okay. Now it's looking clean. And from here, you could do whatever you want with this jar. So we've got the basic jar complete. And if you wanted to add designs on the edge of on the outside or whatever else you wanted to do to the jar, you could. But the basic parametric model is done. So let's test it. So we can change the diameter. Let's just change this to maybe 75. We'll do the height. We'll even go smaller on the height. Let's go 30. And wall thickness, let's do 3. And everything updates as it should. So let's do maybe a narrow one, so 40. And we'll take this up to 75. And we'll take this down to 2.5. And again, everything just updates nicely. Now, if you did not like how I did these threads, or if you wanted like a different shape, like the triangle or whatever, you'll use the same methods that I just used, but you'll have to make sure you create, you know, your clearance here. Make sure when you're creating these and doing your equations for the size of this diameter, that you're going to leave a little gap here. But like I said, I've been using this exact method for threads for a while now, and it pretty much just always works. One thing you might want to do is when you go to 3D print this, you may want to make this threaded portion have smaller layer lines. And let's see, do I have enough time to show you that? Gosh, my videos just get so long. I'm just going to show you how to do that real quick. So let's hide the lid. And this is with Bamboo Studios. I think Orca is probably the same, but I just use the bamboo slicer. So let's just get a quick measurement. So if we click on this surface, hold shift and click on this surface, we're at 50 millimeters. So let's take this to our slicer. So we're going to just file, 3D print this right here and hit OK. The reason I'm showing you this is sometimes, depending on the filament you use, you might, when you're screwing this on and off, it might feel a little rattly. That's just because how this circle prints. It still works perfect. It just may not be like smooth as butter. So how you can change that is add a modifier. So let's say, you know, what are we doing here? We're doing a 0.2 layer height. What you can do is right click on this, go to height range modifier. And what it'll do is take you over to the objects panel here, and you're going to set a range. So you're going to click on this and you're going to do a range from 0 to 50 millimeters. And sometimes you got to click off it a little bit. And look what happens. It's giving you this range from 0 to 50 millimeters. Oops, I'm doing that wrong. We want from 50 millimeters up. So I'm actually going to change this to 50 millimeters to, we'll just do 65 to make sure we're, because I think that's 10 millimeters high. Okay, there we go. So you could do 10 to 60 because I think this is 10 millimeters high. But now basically between here and here, we can change settings. So down here, we could do a layer height of 0.12 or 0.16. I usually like to stay in increments of 0.4. So you could change this to 0.12 and it'll do a 0.2 layer height from the plate up to the screen line, and then it'll do a 0.12 layer height for the rest. So if we slice this, I guess I don't know if we'll be able to see it on the slicer, but basically what it's doing is it's giving us a much finer print on these threads, which will make them operate a lot smoother. Anyways, I hope that makes sense. And then you could do the same thing for the lid if you wanted. You could just print the lid as 0.12, and you could do the same thing. You could still, well, you might not be able to print the lid and the jar then on the same plate because I don't think it can switch between 0.2 for the jar and 0.12 for the lid. Maybe it can. Someone could correct me or let us know in the comments if that'll work. But anyways, that's how you change layer lines. Okay, like usual, I'm rambling again. I hope this helped. Enjoy.